Hello and welcome to the next part of the video. As you have seen in the previous two parts, we were using Scikit Learn to predict the price of the used cars. Okay, and using Scikit Learn, these are the map or accuracies, you can say, what we had achieved with outlier. Without treatment of any outlier, we could achieve a map of 136%, and it was improved to 118% when we had removed the outliers, and when we had removed the used the random state, it could actually further came down to 41%. Okay, so the way we have Scikit Learn for using linear regression, similarly we also have another package called Statsmodel. Alright, so in this video what we are going to do is we are going to run the same linear regression model using Statsmodel. So we are trying to understand, does it help us to make any improvement using Statsmodel in our accuracies? And in this process we will also be able to compare you of linear regression using Scikit Learn and linear regression using Statsmodel. So let's start. So all the things we have done earlier, we had removed outliers, we had segregated them into training and testing variables, we had created dummy variables. Now let's run with the Statsmodel. Now in the Statsmodel, first we have to create a data frame. I'll call it a df equals to, now I'll concat both the training data sets, pd dot concat, within bracket I will write train underscore y and train underscore x, and axis equals to 1, and let's check df dot head. I will quickly check they have been concatenated properly. Yes, they have been concatenated properly. Now we are going to run the model. So in order to run the Statsmodel, you need to import a package called import statsmodels dot formula dot API. This is the name of the package, and then you have to give some name to it, maybe something like rock equals to, sorry, I also need to put an alias to it. I'll name it as sm, so that I don't have to write the entire name over here. I can write sm dot ols, and then I'll be writing formula equals to within quotes I will be writing first the dependent variable like selling price, that is my dependent variable, then tilde, then I will be writing the name of each and every independent variables like this: present price plus kilometers driven. Okay, so once we have done that, then I'll put a comma, and then I'll be writing data equals to, what is the dataset name? My dataset name is df. I'll be writing df, close the bracket, and dot fit, and it's going to run the model. And after that, in order to check the summary, you have to write rock dot summary. So I'll have to write name of all the other variables. So what I'll do is I'll quickly copy it, which I have already written in the exactly same format, and then you will execute it. Now you can see there is a bunch of different statistics over here. So I'll explain the important ones to you. What you need to check, the first you need to check is the probability statistic, this one. So all you need to check is this value should be less than 0.05. okay, this is called ANOVA. So in another video I'll be explaining this to you, but I'll quickly explain, though you might not be able to understand if you do not know it already. So it is related to your hypothesis testing. The null hypothesis says all the coefficients are equals to 0, alternate says at least one of the coefficient is not equals to 0. So p value less than 0.05 means that we reject the null hypothesis and we consider that at least one of the coefficient is not equals to 0, and we can proceed with the model. So then what you need to do is you need to check the p-values of all the independent variables. So all you have to check is, do you have any variable? This is the base intercept. Base intercept, you are not going to do anything, just leave it alone. All the independent variables, you need to check whether the p-values are less than 0.05. If they are less than 0.05, they are fine. If they are more than 0.05, not fine. That means we need to remove them from our model. So we can say there are a couple of variables where the p-values are more than 0.05. So we need to remove them, but we need to remove them one at a time. So which one to remove first? In order to understand which one to remove first, you need to check the t value. For all the variables where the p-values are more than 0.05, you need to check where do you have the lowest absolute t value. Among these three, I can see the lowest absolute t value will be your transmission manual, 0.349. That means it's the least important variable in this model. Okay, so what I will be doing is I'll copy this one, paste it over there, and delete where do you have transmission manual, and delete it. Again you execute it, check do you have still any variable more than 0.05. Yes, we do. And which is the having the lowest absolute t value? Yeah, fuel type petrol, this one. Again we will be removing them. I am not copy pasting this code once again, but it's a better practice, you copy paste every time. So fuel petrol, I will be removing them from my model, and again you execute that. Now do you have any p value more than 0.05? Still we have owner. We cannot have a single variable which is more than 0.05. So delete the owner and execute it. Now there is no more single variable where p values are more than 0.05. We are fine with it, so we can proceed with it, no problem. Alright, now the next part what you need to check over here is R square. R square tells you the goodness of fit. So R square ranges from 0 to 1. 1 means the best, 0 means the worst. It's 86.5%, which is fairly good. We have adjusted R square. Adjusted R square tells you whether there is any redundant variable. If you have any redundant variable which is not making any sense or which has a very high correlation, then R square will increase. Okay, unnecessarily inflate, whereas adjusted R square will not inflate. So adjusted R square and R square should be pretty close to each other. Okay, the closer it gets, better the model. So I can see it's 86.5, 86.2, pretty close, so we don't have any problem. So that means my independent variables together as a whole can explain about 86% of the variance of the dependent variable. So we can proceed. Now we need to check what is called VIF. VIF tells us the correlation among the independent variables. The theory says there should not be any correlation among the independent variables. There should be zero correlation, but in real life there will not be zero correlation exactly, but there is a limit up to which we can tolerate the correlation among the independent variables. So there is a code which I'll simply copy paste again, just interest of time. This is your VIF code. You can just use the same code for all data sets, except if you here I had named it as Rock, which happens to be my favorite wrestler. If you are using any other name over here, maybe Brock Lesnar or Boogeyman, so you just need to, wherever I have written Rock, you just need to change that. Otherwise they are exactly going to be the same thing. And you execute it, and you need to check the VIF. And I have taken a threshold, VIF threshold of 3. Some of the other projects might take them as 5, or financial projects might take them as 1.5. I have taken them as 3 depending on the project. So do you get to see any variable more than 3? No. So we are fine with it. Had it been a case where we have a variable of more than 3 VIF, then I would have gone to this step and I would have deleted that variable and again rerun the model, check their p-value and come back and check their VIF. So we don't have any VIF problem. So we are good to move ahead. So now what I'm going to do is I'm going to just predict it. Okay, so in order to predict it, I'll again create another data frame where I will be concatenate the training data sets, so it will be easier for you to understand. pd.concat and test underscore y comma test underscore x is equals to 1. Okay, you can quickly check it. Yes, this is the testing part which we had left out. And now let's predict df1. I will create another column in it as pred equals to rock dot predict and test underscore x. So this is what we have predicted, and we can also quickly check df1 dot head. So see, we have got a column which is the predicted values of the selling prices. Okay, these are all the predicted values. Now I'm going to check for the MAP. I can go back over here, or if I can quickly copy paste the MAP, this one, simply copy paste it, calculate the accuracy. Alright, and for it, for testing y, I can write df1 within bracket pred, where I have saved all these things, this column, comma df1 within bracket, and this is my dependent variable. I need to compare these two. Okay, and check. See, now my MAP has been 36.8%. So with using Statsmodel 36.8%, so that means we can further bring it down to 36.8%. Okay, now in the next video I'm going to show you how we can use some other algorithms and try to further push down the accuracies, or rather improve the accuracies. So stay tuned, and please like our videos and share our videos, and you can go to our website analyticseducator.com for more updates and our courses.